Okay, today we're going to look at perhaps the oldest card deck stacking system ever. It's called Si Stebbins. That's the name of it. And then with this special arrangement of the cards, you can actually do a lot with it. So let me just show you how you build a Si Stebbins deck to begin with. So what I have here is I have ace through king, with the king on top descending down to the ace at the very bottom. And I've done the same thing with the hearts, spades, and diamonds. So that's how you begin. So to build your packet, what you need to do is just move the ace to the top. Okay, so we'll have an ace of clubs on top. And now we're going to move all of the cards above the four of hearts to the bottom, so that the top card is the four of hearts. Now we'll move all of the cards that are above the seven of spades to the bottom of that packet. And then we'll move everything that's above the 10 of diamonds to the bottom. Okay, so this will be the value arrangement. So we have an ace, which you can consider to be kind of equal to 1. So we have like a 1, 4, 7, 10. So if you notice, the consecutive cards here differ by 3. So you just add 3 to the ace, counting as a 1. You get 4. 3 plus 4 is 7. 3 plus 7 is 10. In fact, that will be helpful to remember, because when we go to use this deck, we'll need to remember that card values are off by a difference of 3. Also, you may notice that we have the suits in a special arrangement. This is called chaste order. So let me just show you that really quickly. So chaste ordering is as follows. It's an acronym here. So it stands for clubs, hearts, spades, and diamonds in that order. So if you can remember the word chaste, it will help you remember the order of the suits that we will be using. And as mentioned already, the card values differ by 3. Okay, so let's go ahead and build our special Si Stebbins stack here, or deck. So what you do is you take a card from the clubs pile, put it on the bottom, and then take one from the hearts, spades, diamonds pile. Okay? And then you just repeat that. Clubs, hearts, spades, diamonds. Clubs, hearts, spades, diamonds. Now I'll probably go ahead and jump to the end of this process, because otherwise you're going to fall asleep. Okay, we're getting down to the final few here. 2 of clubs, 5 of hearts, 8 of spades, and jack of diamonds. That completes our Si Stebbins stacking of a deck of 52 cards. Okay, well, what can you do with this special arrangement? Well, to begin with, it's called a cyclic deck. And it's cyclic relative to a number of cycle structures. So for example, let me just show the cards here. One thing you'll notice is that it alternates in color. Red, black, red, black, red, black, all the way through. And that's because we stack them clubs, hearts, spades, diamonds. Because of the clubs, hearts, spades, and diamonds, we also have a repeating pattern of suits. Clubs, hearts, spades, diamonds. Clubs, hearts, spades, diamonds, all the way through the deck. Now the other repeating pattern may not be as readily perceivable, and it's the fact that the card values cycle through every 13 positions. So for example, we have ace, 4, 7, 10, king, 3, 6, 9, queen, 2, 5, 8, jack. So let me just break it there. And then it repeats. Ace, 4, 7, 10, king, 3, 6, 9, queen, 2, 5, 8, jack. And then it repeats again for a total of 4 times. So we have a cyclic structure relative to card values, where the card values repeat in groups 4 times throughout the deck. Okay, so that's kind of a bird's eye view of this structure. Now, if you've studied a little bit of card magic, you'll know that because this is cyclic, that means you can actually freely cut the deck, and it will not destroy the fact that, for example, it's alternating in colors throughout. Now, it may start at a different color. In fact, it does. Now it starts at red, black. But the fact that it alternates in color will not be harmed by cutting the cards. The fact that it alternates in suits will not be harmed. So this time, for the top card, it's hearts. Hearts, spades, diamonds, clubs. Well, look, hearts, spades, diamonds, clubs. So that repeats over and over for a total of 13 times. 13 times the cycle length 4 is 52. And then if you check it, the card values repeat every 13 positions throughout the deck. So that's something that is worth remembering, that you can actually cut this Si Stebbins deck and it will not harm the fundamental structure as a special cyclic arrangement with which we can do quite a bit. Okay? Now, because you're free to do cuts without harming anything, if you have watched my video on the Charlier Shuffle, then you'll know that you can actually perform as many Charlier shuffles as you like without harming the deck. And a Charlier shuffle is quite a bit more convincing than just cutting the cards once. So how this works is you push over a certain number of cards, and then from the bottom you push over and deposit a certain number on top. From the top here you push over a certain number and deposit them at the bottom, and then bottom to top, top to bottom, bottom to top, top to bottom. And you can do as many Charlier shuffles as you like, because each one of those is equivalent to just cutting the cards at some location. Okay, so that will not harm our special structure here. But boy, is it convincing as a mixing procedure in the eyes of most spectators. They think the cards are being sufficiently scrambled, when in fact they're not. Okay, so let's show you some of the amazing things that you can actually do with this arrangement. And I do want to point out something important. It's a bit of work to set up a deck this way, as you might imagine. So what most card magicians will do is they'll have a dedicated deck to just this arrangement of the cards. And so on the outside, they might write Si, it's, the name's right here, Si Stebbins, and then leave it with that arrangement, okay, and not use it for other purposes, so that if they want to do an effect that requires the Si Stebbins ordering of the deck, they can just grab that packet of cards and they're off to the races, okay? So you would not really need to rebuild this every time if you just have a deck dedicated to this particular arrangement of the cards. Okay, so let's show you some of these things here. So number 1, name the top card after a random cutting. Well, maybe before we do that, let's just do a little bit of practicing here. So if we know the identity of the bottom card, which we can see is the 6 of spades, what must be the value and suit of the top card? Well, think about how this deck was made. So if you want to imagine just moving this one card, and setting it on, whoops, I'm giving it away, setting it on top of the 6 here, what would its value and suit be? Well, all we need to do is add 3 to its value, so we get a 9, And then we need to remember clubs, hearts, spades, diamonds. Diamonds comes after spades. So the top card, if we see that the bottom card is the 6 of spades, then we already know something. We know the top card must be the 9 of diamonds, which it is. Okay? So no matter how you cut it, you can immediately state the identity of the top card. Now you do have to do a little bit of thinking when it comes to the face cards. A jack is counted as an 11, queen as a 12, king as a 13. So if you add 3 to 9, you get 12, which is a queen. The suit that follows hearts is spades. So the top card should be the queen of spades, which it is. Okay? Let's do just a few more here. Oh, this is a good one here because it's, a harder one to think through. So here I have a jack. So think 11. Well, if you add 3 to 11, what do you get? You get 14. Now we only have 13 card values in a standard deck of cards. A king is a 13. So 14 would have to be the card that follows, the one that's, quote, after the king. Okay? So one way to think about it is think about 14 and then mentally rewrite it as 13 plus some other number. Well, 14 is equal to 13 plus 1. So the card value for the top card here must be an ace. And its suit must be a club because we're wrapping back around. It's clubs, hearts, spades, diamonds. After diamonds comes clubs. So it'd be ace of clubs at the top, which it is, ace of clubs. Okay? So I think that's the first thing to do is just practice a little bit. Here we go. Here I'm getting all the face cards just randomly here. Okay, so I have a king. Well, if we add 3 to that value, we get, of course, 16. What is the card that's 3 away sequentially from the king? Well, it's the 3. And because it has a suit of hearts, it would have to be the 3 of spades on top, which it is. Okay? So we're essentially doing arithmetic modulo 13. Because 13 for the king's value plus 3 is 16. Well, what is the remainder if 13 is divided into 16? Well, the remainder is 3, right? 16 can be written as 13 plus 3. Okay. So, boy, we're getting all the hard ones here. Okay, this one's easier. So we add 3 to the value of the card, so we get 10. What comes after hearts? Spades comes after. So this would have to be a 10 of spades up here. Okay? So in particular, what this would mean then is if you were to, perhaps perform a Charlier shuffle or just have the deck randomly cut, and then if you were to kind of square it up, catch a little peek of the top card there as you square it up, which is, a natural thing to do. You're just straightening up the cards. You can see that there's a king of hearts on top. So you add 3, it's going to be the 3, and the suit that follows hearts is spades. So without the spectator even really knowing it, you know the identity of the top card after a random cutting of the cards. And if they don't catch you kind of glimpsing that bottom card, it's going to be inexplicable to them that how could you possibly know that the top card is the 3 of spades. Okay? But you do, and it's mathematics that allows you to state that. Okay, so with that little bit of practice, let's go ahead and look at number 1. So it builds on some of the skills that we were just looking at. So what this involves is you just kind of thumb riffle down the side of the deck, and ask the spectator to tell you when to stop. You'll just stop randomly. So maybe you stop there. So what you do is we're going to cut this to the bottom. But this gives you plenty of time to spot the identity of this bottom card. Okay? Now you have to realize the spectator hasn't a clue that the identity of the bottom card will in any way help you know the identity of the top card. They haven't a clue, okay? Unless you've kind of given away something. Okay, so remember, a queen is a 12, plus 3 is 15. 15 can be written as 13 plus 2. So we're looking at the 2, and then of course it's the spade here. After spades is diamonds. So you can just immediately state, I think this feels like the 2 of diamonds. Oh, I got it. Okay, so you would just have the spectator tell you when to stop, and without making a big deal of it, kind of glimpse the identity of that top card. This one will be fairly easy. So you see that it's a 10 of diamonds. So think 10 plus 3, 13. Well, that's the king. What follows the diamond? Well, the club. So this will have to be the king of clubs, which it is. And you can get really, really fast at this. And all you have to do is catch a little glimpse. The key here is to not stare. Don't look directly at the back. Just kind of look above or almost look at the spectator, but out the corner of your eye or out of the bottom portion, I guess, of your peripheral vision. So this is a jack, which is an 11. So 11 plus 3 is 14. And so that would have to be an ace that would follow it. And so, of course, what follows hearts is spades. So this one is an ace of spades, and you can state that. Okay? Okay, let's do another one here. So you just kind of, you don't show them the bottom card like this. I mean, you just, the key is to, in the process of kind of moving that top portion that the spectator has dictated as, okay, cut there and move it to the bottom, that's when you glimpse it, okay? Now, for educational purposes, I'm kind of leaving it up for you to see. But you just quickly glimpse it. So I see a 6 of hearts. So in your mind, think, okay, 6 plus 3 is 9. I know the card value. What follows hearts? Spades follows hearts. So it'd be 9 of spades would have to be the top one, which it is, okay? A 10 plus 3 is a king. King of hearts, of course. Oh, finally, we got something different. 4 plus 3 is 7, so it's a 7. Clubs is hearts, 7 of hearts, okay? So practice that. It won't take long. So you glimpse a 2. 2 plus 3 is 5. What follows hearts? Spades. So it's 5 of spades, okay? And when you do this over and over again, the spectator is going to just be absolutely blown away that you could possibly know so quickly the identity of the top card where you've cut the deck where this spectator asked you to. That's the surprising part. Okay, number 2 builds on what we just learned in number 1. So how this works is you can name the 27th card from the top after random cutting. So we're back to random cutting again. Maybe the spectator says, cut there. Okay, so you spot a 2. Okay, so you add 3, so it's 5. What follows? The clubs, hearts, 5 of hearts. So you know, let me just show you, you know that the top card is the 5 of hearts. Well, you actually know more than that, because once you know the identity of the top card, its, quote, companion card will be 27 cards away. What does that mean? Well, if the top card is the 5 of hearts, its companion card is the other red 5, which is the 5 of diamonds, okay? So what that means then is if you count down 27 cards from the top, you'll arrive at the 5 of diamonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. Okay, so you'll arrive at the companion card. The 27th card will be the companion card to whatever the top card is. Okay, same thing here. The King of Diamonds would be the 27th card down. Okay, so the way in which you're building on the skill in number 1 is you go ahead and ask the spectator to tell you when to stop right there, and then move. So can you see what I'm doing here? As I move it to the bottom, I can kind of angle it towards me a little bit so I can see it. Once again, they have no idea that this tells you anything. So you see a 7, and you're given just a few seconds to think 7. Okay, 7 plus 3 is 10. It's hearts now. What follows hearts is spades. So it's 10 of spades. You know, you don't show the top card, right? So we're going to get to the companion card, which is the 27th card down. So you first note this. From here, you deduce, okay, what must the top card be? Without looking at the top card, from there, you deduce where the companion card to this one is, okay? So because this is a 7, we're looking at 10 and then spades for the top. That means 10 of clubs will be the 27th card down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, so you're kind of using this skill as a stepping stone to being able to name the 27th card from the top. Okay, number 3 here is called perfect estimation skills, and this is a really fun one to perform. Now, I recommend that you have a high card value at the bottom before you begin this. So you can do that in a number of ways as you show the cards. King is ideal to have a king at the bottom. You can just kind of casually switch those so that you have a king, if you didn't already, have a king of any suit at the bottom, and you'll see why. Okay, so if you start with a king at the bottom, it actually makes things easier for you as the performer. Okay, so what this looks like is, it looks like you're just randomly cutting a block of cards and then just using the weight of the cards or the thickness of the cards or your training with the cards, you're somehow going to be able to perfectly state how many cards are in that randomly cut packet. Okay, so that's what it looks like to the spectator. Now what you're going to do is a little bit of mathematics to figure that out. And so how this works is if I randomly cut a portion of the deck like this, okay, and I pretend to kind of go, I wonder how many cards are here. I do need to catch a glimpse of the bottom card. Now ignore the suit, which is kind of nice actually. Just focus on the value. Okay, so I just need to spot that that's a 5. Okay, so to state the exact number of cards here, what I need to do is I need to know the bottom card, which is a king, so that's a 13. And then I need to spot the bottom card of the packet. So for my variables here, just to point this out, the D represents the value of the bottom card of the deck, the whole deck, which is 13, it's a king. P represents the value of the bottom card of this packet that you've randomly cut, which is 5. Okay, so that's what the D and the P represents. So all you need to do here is take those two values and subtract them. So 13 minus 5 is 8. Now that number needs to be multiplied by 4. Okay, so 8 times 4 comes out to be 32. So 32 is what we get so far, 32 for that calculation. And then from there, you may have to do an adjustment to that number depending on just common sense evaluation of how many cards you think you have here. So we got 32 out of this calculation. Looking at this, do you think there are 32 cards here, when indeed there's 52 in the whole deck? Well, no. Half the deck is 26. This is far less than half the deck. So what you need to do is you may need to either add or subtract 13 from the computed value here. So right now we have 32. So if you subtract 13, you get 19. So there should be 19 cards here, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We nailed it. It's exactly 19. Now, if you notice what I didn't reverse count. I'm not changing the order of these. I'm just counting them while maintaining their current order. We do that so that you can now set this on top. You can perform a random cut if you would like, though I guess that's going to affect your king at the bottom, so maybe don't do that in this particular case. But we can repeat what we just did with the perfect estimation skills. So why don't we go ahead and cut off a big chunk here, more than half. Okay, well that looks like more than half, not a lot more, but that's probably more than 26. Okay, so I need to spot the bottom. Oh, we see a queen. Queen is 12. Now remember, the bottom card started out to be, quote, a 13, a king. So we need to take 13, subtract 12, that's 1, right? So 1 times 4 is 4, okay? Do I have 4 cards here? Certainly not, right? Now we need to add 13 and then kind of reassess. 4 plus 13 is 17. Do you think I have 17 cards here? I don't think so, right? This is right around half the deck. Well, if 17's not right, then we need to add 13 again. So that would give us 30. So apparently we have 30 cards here. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. We nailed it again. There are exactly 30, okay? And when you go to count those, as I did here, it is effective to slow down the counting at the end because it kind of heightens the anticipation of the spectator. They're thinking, there's no way you got that number exactly. And so as you slow down the counting of those final cards, they're going to go, it added up. He got exactly the quantity of cards that were randomly cut. Okay, so why don't we do one more? We'll do maybe a smaller one. Okay, so this is very, very small. What's the bottom card? It's a jack, which is an 11. So the king, 13, minus the jack, which is 11, leaves us with 2. 2 times 4 is 8. Does it appear that we have 8 cards? Well, the alternative is that we have 8 cards plus 13, which would be 21, which is almost half the deck. We don't have anything close to half the deck. So it looks like it will, in fact, just be 8. 1, 2, 3, 4, 5, 6, 7, 8. And it is. Okay. So I will probably leave it as an exercise for you to see if you can puzzle through why this formula works. And I think as you work with it, you'll develop an intuition for what's going on and realize, oh, this is exactly what you need to do. Of course, the 4 is here because of the suits, cycling through, right? And the 13's here because of the card values, cycling every 13 positions, okay? And then I have this note over here. You may have to add or subtract 13 more than once. And we saw an example of that where I had to add 13 twice. We got a number of 4. Remember, we got a count of 4 over here because we got a 1 and then times 4 is 4. And then we had to add 13. We got 17. It was more than 17 cards, so we added 13 again, and that bumped us up to 30. And 30 was the right answer for that packet. Okay, so that's called perfect estimation skills, a really fun one as well, and pretty surprising for anyone watching it. Okay, the 4th one is something called naming the top card of multiple random cuts. Okay, so let me explain how this one works. So what you do here is, in fact, I have a little diagram here that will prove helpful for number 4, so maybe I'll just put that on top right there. So picture the deck as made up of 4 different portions. And those portions will be determined by kind of randomly cutting a number of cards. Okay, so we're going to have 4 little packets that come from cutting the cards at random locations. Okay, and then imagine those cut packets. Well, I will actually align them from left to right. So this will be the top cut portion. 1, 2's the second, 3's the third, 4's the fourth. Okay, so in your mind's eye, if you can kind of see them listed that way, it will actually help. Okay, so I'm going to just cut off some number of cards. This will be our pile 1 right there. And then cut off a number again for pile 2. And then cut off a number here for 3. And then whatever's left over will be 4. That will be the bottom portion. Now these are not equal in quantity by any means. You might not be able to see that, but I can see that these are quite different. Okay, so what can we do? What do we know because of the Si Stebbins arrangement of the cards? Okay. Well, I have some arrows over here, so maybe I'll just move these down for a second. If you think about, this was the top. That next portion, see, 1, 2, 3, 4, just like listed there, okay? Well, we know that the bottom card of this one was the immediate neighbor to this one. That's how we got it. We cut off that little packet. So that was there, right? This one was there, and the same thing here, okay? So we do know something. There is a relationship between the bottom card of each of these and the top card of one of the other packets. Okay, so one thing you could do among many things actually is you could even have the spectator do these random cuts actually, and ideally that would be best, because then they would feel like, oh, okay, I've just kind of randomly cut. There's no way that the performer is going to know, where I cut it, because I decided where the cuts would be, okay? Well, what you could do is just tell the spectator, let's see where you cut each of these. So you just turn them face up. So we're just looking at the bottom card. We're not looking at the top card, right? We're just looking at the bottom. And you may see something interesting, like right here. That's kind of fun, that you've got 2 jacks and then a king, okay? And then you can tell the spectator that you're going to, quote, write a prediction, okay? And that these 4 random cards are going to help you be correct with your prediction. So what you can do is write down the identity of the top cards of each of these 4 packets. Now you can quickly deduce what they are, because we know that the bottom, so if you follow my little arrows here, the bottom card here, the 4 of hearts, is the neighbor to the top card of this one. Okay? So all I have to do is look at the 4. So if you want to list them really quickly, you can say 1, 2, 3, 4. Now the spectator's not watching you. You just claim that these 4 cards, which were randomly arrived at, are very, very special cards. In fact, they're going to enable you to state the identity of the original top portion of each of these cuts. Okay? Now that's going to be quite unbelievable to the spectator because they are the ones that cut the cards. Well, the way that you can do it is you just look at the bottom card here and you know that it's the immediate neighbor to the top one here. So if you look at my little diagram, the bottom card, this packet of, I've labeled 1, was on top of 2, right? 1, 2, 3, 4. So to get the identity of the top card of this second packet, all I need to do is add 3 to the 4, so it's going to be 7, and then just move 1 over in our clubs, hearts, spades, diamonds. Okay, so this information here tells me that the top card of this packet is going to be a 7 of spades. This card here tells me that the top card of this packet is going to be, so with Jack is an 11, so you add 3, that's 14. Well, 14, it can be written as 13 plus 1, so you have like a remainder of 1. So it's going to be an ace. What follows? Clubs. Clubs, hearts, spades, diamonds, right? So hearts. Now this card here tells you or gives you information about the identity of the top card here. So it's also going to be an ace. Isn't that fun? So it's going to be an ace, but this time what follows? Hearts. Well, it's a spades. Okay? And then if you notice, what will happen is the very bottom card of the 4th packet, so right here, is going to tell us the identity of the top card here. Okay? And that has to do with the fact that the deck was stacked. This is the top portion, 2nd, 3rd, and this was the very bottom of the deck, right? And we know that the bottom of the deck, the identity of that card is related to the top card of the deck in this way that we've been talking about, where you need to add 3 to the card value and then move 1 over in the ordering of the suits. So a king. Well, king, if we add 3, we're going to get a card value of 3, right? King is the highest value, it's 13. So what would follow a king in this ordering would be a 3. What follows a diamond? A club, right? Clubs, hearts, spades, diamonds, and then after diamonds, clubs comes next, and it repeats. Okay? So just to review, the identity of this card tells you, or can be used to deduce the identity of the top card here. The identity of the bottom card here can be used to deduce the identity of the top card here. And then the identity of the bottom card here can be used to deduce the identity of the top card for that first packet. Okay? And so you can claim that, boy, you just happened to cut these packets so that these bottom cards enabled you or whispered to you or whatever narrative you want to come up with. It's really quite nice here because we actually have face cards. So they have pictures of people, and since they all have mouths, we could claim that they're whispering to you the identity of the top cards of these packets. Okay? So however you want to kind of frame that. But it is true that these 4 cards are giving away the secret of the top card of each of these packets. So now you can turn them over. So you haven't shown this yet. You've just written your, quote, prediction. Turn these over. And then there's a few ways to proceed from here. One would be to go ahead, to still have this kind of folded, and you haven't revealed it yet, right? And then have them just turn over the top card of each of them. And to the spectator, these are going to look pretty random. Right? I mean, they are random, right? Because they randomly cut the deck into 4 portions. So these truly were randomly arrived at. But their order within this Si Stebbins arrangement of the deck is not random, right? Because of the bottom card giving you information about the top card of the packet to its right there. Okay, so the spectator will see this and go, okay, what am I to get from that? And they'll say, well, isn't that interesting? I claim that those bottom cards could reveal to me the identity of the top card where you freely cut the deck into 4 random portions. And then you can just open this up and reveal that you have a perfect prediction. 3 of clubs, 7 of spades, ace of hearts, ace of spades. Okay, so that's another way to take advantage of the information contained in this Si Stebbins arrangement of a deck. And it's one that you could probably frame this in a number of different ways. And so if you want to come up with a different narrative for it, that would be great. So if you remember, this is 1, 2, 3, 4. So to put it back where it was, where we haven't harmed the structure in any way, that's how you would stack them. And so we're back to our Si Stebbins arrangement of the deck. And then I just have this note here. Given the identity of a bottom card, simply add, comma should be over here, simply add 3 to its value and shift its suit to the right to obtain the identity of the corresponding top card. So this little diagram kind of shows you how that works. So anyway, that's another fun routine that you could actually perform using the Si Stebbins deck structure. Okay, very good. Now the last one is a big one. And I probably will eventually put together a whole series on the Gilbreth principle because there's just so much to talk about here. So if you're familiar with the Gilbreth principle, you'll realize there's a lot that you can do with a Si Stebbins arrangement. But a consequence of a Gilbreth performance is the Si Stebbins ordering will be destroyed. Okay. Now that's not all bad if you were able to come up with a very surprising and engaging routine for the spectator, so it may be worth destroying your Si Stebbins arrangement for that purpose. What we could do is just think about this for a moment, and you'll be able to kind of see why I would come up with these different numbers to work with. Remember, focus on the colors. The colors alternate. Red, black throughout. Okay, that's nice. So if you have an even number of consecutive cards, it's going to be, quote, cyclic. It will have that repeating of red, black throughout. Okay. The same thing for groups of 4. So if I take 4 cards, so for example, if I took just 8 cards, it will have that arrangement. In fact, maybe we'll just do that. So why don't we go ahead, we'll focus on the suits first, and then maybe we'll focus on values, and then we'll focus on the alternating color of the cards. So what I'm going to do is I'm going to just deal out 8 cards. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this will be for our suits. We're going to focus on the fact that the suits cycle through. And so here, the suits will cycle through twice, right? Because there's just 8 cards. If we want to do values, the values cycle every 13. So we would need 26 here. So why don't we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6. Okay, so this bigger one, it consists of a cycling of all 13 twice, okay, because we have 26 cards here, and 13 divides into 26 twice. And then the remaining cards will have an alternating red-black structure that we could take advantage of. So there's 18 cards here. Now, it's not so important how many cards are here, as long as you have an even number. You need an even number to preserve that alternating nature of the colors of those cards. Okay, so this one here alternates in color. This one here alternates in suits. This one here alternates in values. Okay. Well, what is a Gilbreth performance? So why don't we go ahead and we'll start with this one here. Okay, so what a Gilbreth shuffle is, it's a riffle shuffle. So I'll show you what a riffle shuffle is in a second, or if you don't know already. It's a riffle shuffle in which you have reverse counted a certain number of cards from the top. In fact, why don't we go ahead with another deck here and just show you, quote, what is a classic riffle shuffle. So a riffle shuffle is where you just have a deck and you break it off anywhere. Most people try to do about halfway, and then you have the cards fall how they may, left, right, okay? So this is called a riffle shuffle, okay? Now, for smaller packet sizes, there are equivalent ways of achieving this same sort of mixing of the cards that I'll show you. Because to do this kind of shuffle for really small packets like this one of 8 is hard to do. And you can try and you'll realize it's a bit tricky. So I'll show you an equivalent way that's actually aesthetically more attractive as a shuffle. Okay, so how this works, now these are the cards that alternate in color, right? Red, black throughout. Okay, so this is what we call a cyclic construction or cyclic packet. So the Gilbreth principle says the following. If you reverse count, this is reversing the order of the cards, right? Because the very top card is now at the bottom of that packet. We're reversing them. Reverse count any number of cards, and then you, quote, riffle shuffle these together. Some very important characteristics survive that process, okay? So what we may do here, since they're very small groups of cards, we're going to do something that's equivalent to a riffle shuffle. It's called a rosette shuffle. So this is where you just kind of spin the cards and then just bring them together and have them kind of interlace however they will. Okay, it really is random. So this is equivalent to doing a riffle shuffle like the one I showed you just a moment ago. Well, at this point, the Gilbreth principle is in force. And what is the Gilbreth principle? Well, the Gilbreth principle says that because we had this alternating black-red structure, what will happen is pairs of cards from the top will consist of one of each color. Now, we won't know the order of the cards necessarily. Okay, so for example, see, here's one pair. There's the second pair. Well, notice that we have red, black, and now it's black, red. But what you are guaranteed is that each pair of cards will consist of one of each color. Well, if we know that this happens, there's many things that you can do that are very surprising using that outcome as the engine driving your effect. Okay, so one would be just, showing the spectator that despite the fact that they saw those cards coming together in that rosette shuffle in just kind of a messy way, how could they have come together so perfectly so that every pair has one of each color? Okay, so that's really quite inexplicable in and of itself. We could have turned it into a little bit of a betting routine where kind of go back in time. So here we've Gilbreth shuffled it, and you could have the spectator decide, okay, the pair will be a winning pair for them if these two are of the same color. It's a winning pair for you if they're opposite color. Well, it ends up that that's a fair, quote, fair game to play, because there's just as many ways for these two cards to be of the same color as there are ways for them to be different. So it truly is a fair game. So you can say, okay, so you win if they're the same color, and I win if they're different colors. So you push off two and go, oh, okay, that's a win for me, right? Okay, now what about, oh, I won these as well. Surely you're going to get a pair of the same color here, right? Nope, you lost that one. Oh, you've lost that one. You've got to be the most unlucky person ever. Are you going to win any? No way. How in the world did you rosette shuffle those in just the right way, where the outcome of this little game guaranteed that I would win and that you would get no matches whatsoever? Well, the reason that you got no matches of color in the pairs is because of the Gilbreth principle, okay? Because the Gilbreth principle says that in pairs for this packet, they have to be of opposite color, okay? So we're not going to go too deeply into why the Gilbreth principle works, because that could be a whole series, actually, to be able to pull that off. Okay, let's go ahead and apply the Gilbreth principle to this little packet. Now, secretly, you know this. You know that this is a cyclic construction of the four suits repeating twice. So you have diamonds, spades, hearts, clubs. Diamonds, spades, hearts, clubs. So this is a cyclic packet. So the Gilbreth principle applies. So now we perform a Gilbreth shuffle. What is that? This is where you reverse count any number of cards, and it truly can be any number. Maybe we'll just do 3 instead of half of them. Okay, and then you riffle shuffle these together. That's a bit tricky to do with so few. So just do this little rosette shuffle instead. And I need to really emphasize I'm not in any way controlling how those two little packets interlace. I'm not. I suppose a person maybe with a lot of practice could achieve that, but that would be hard to do, and is not happening. You could even have the spectator do that bringing together, right? But what does the Gilbreth principle say? Well, the cycle length here is 4. Cycle length means how long is the pattern before it repeats again. Well, for the black, red, black, red, black, red, the pattern was 2 elements. A black card and then a red card. A black card and then a red card. So that pair of colors repeated throughout. So we would say that this original packet, the cycle length is 2, because the cards repeat in color every 2 cards. Okay. Now, what happened in this one here, because of the suits repeating, the cycle length is 4. And it's because there's 4 suits. Okay, so what does that mean for the Gilbreth principle? That means after we've performed our Gilbreth shuffle, which is what we just did, if you push off the top 4 cards, these 4 cards are guaranteed to have 1 of each suit. We won't know the order of the suits, but we do know by the Gilbreth principle that there must be exactly 1 of each suit. Okay, and let's just check that. And yes, indeed, there's 1 of each suit. Okay, I'll push it up here and then kind of show you that we get a different order. And then the Gilbreth principle continues to say, okay, this little packet of 4 cards, will consist of one of each suit as well. Okay? And then just look. The ordering of the suits is different, right? There's clubs, hearts, spades, diamonds. Boy, that's the original order. Here, now it's diamonds, spades, hearts, clubs. Okay, so it's a different ordering of the suits, but what we are guaranteed is that each group of 4 from the top will have exactly one of each of those 4 suits. Okay, so that's the Gilbreth principle applied to this little packet of 8 cards, where it started out with a repeating pattern for the suits. Okay, and then remember, for this last one, this last packet has a repeating pattern of the card values. So the card values repeat after 13 positions. Okay. Well, if we perform a Gilbreth shuffle on this, we just deal out a certain number of cards. It actually doesn't matter how many. The spectator can kind of tell you when to stop dealing. Okay. We could actually do a rosette shuffle for this one as well. It's going to be a little bit bigger one here. This is equivalent to a riffle shuffle. Okay. And just look at how those cards are kind of just randomly interlacing there. And they really are. Okay. Well, what does the Gilbreth principle guarantee us? That if I take the top 13 cards, there will be a card of each of the 13 different values. So none of the card values will repeat in that top 13. So let's just count them off. Let's get 13 of them first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so here's the first group of 13 cards. Okay, and we'll just kind of take a look at those. And we're left with 13 cards because if you remember, we dealt off 26 because we wanted this original repeating pattern of the values to occur twice. Okay, so we have 26 cards. The Gilbreth principle says that this little packet of 13 cards will only have exactly one of each card value. Okay, and so we can check that. So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And that's all of them. Same thing here. Each card value appears exactly once. So we have ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay? And that's guaranteed to happen in this situation here. If you have those cards repeating in value twice in blocks of 13 cards, and then you perform a Gilbreth shuffle, which just means you reverse count some of the cards and then, quote, riffle shuffle them together, you're going to get an outcome like this. Well, because of the predictability of the ending structure for these different packets, you can come up with many different card effects based on this most remarkable principle. So it's called the Gilbreth principle. Okay, so it's because of the Si Stebbins structured organization that you can actually take advantage of the fact that the cards originally alternated in color, that they alternated in suits, and then they alternated in values. Okay, so there's a lot that you could extract from this one deck. But the point that I made down here, of course, is after we've done a Gilbreth shuffle, we've destroyed the Si Stebbins organization. And all that means is you just have to rebuild the deck in the way that I showed you at the beginning of this video. That's all that means. But if the purpose is to share a fun card effect with family or friends, then that's a price that you'll probably be willing to pay. Have to rebuild this deck again for later use. Anyway, that's 5 of many, many applications of the Si Stebbins ordering of a deck of cards, and that should keep somebody busy for a while and mastering some of these various skills. But once you have them, they really are astonishing to any spectator who's not aware of the Si Stebbins deck structure. Okay, well, very good. So, so play with that, and you can look up online, I'm sure, many additional applications and routines that use this most remarkable organization of a deck. And these are 5 of the most popular ones. The one here is original. That's one put together for the video today. That's where we have the 4 packets. So anyway, have fun with that. At the heart of all of this is mathematics, once again. And the mathematics, if you look at the level of mathematics here, is not really complicated math. It's fairly simple math. And so for that reason, I've put it under the Simple Math Card Magic playlist. So I hope you enjoyed that, and take a look at some of the other videos in my Simple Math Card Magic playlist. And also take a look at the playlists that fall under the Extreme Math Card Magic, because those are a lot of fun to watch and actually perform, because I give you write-ups for those as to, okay, step 1, step 2, step 3. I show you exactly how to do them. The only thing that may be a challenge, unless you have a bit of mathematics under your belt, will be understanding why they work. But there are plenty of card effects out there that people are happily using where they haven't a clue why they work. They just call them self-working card magic. So I think you would enjoy any of the card effects on my channel that I've called Hidden Structures.